Here are the assignments for 11.1 Part 2. If you want to look at this more, pause the video so you can look at it. Today we're going to look at Section 11.2, Part 1, Composition of Functions. Composition of functions can be written in two ways. Both of these things, this f little circle g and then parentheses x, and this f parentheses g parentheses x, both of these mean the same thing. It's called f of g of x. It is not f times g. It is not fog. It is f of g of x. And what this basically means is that you take the entire g of x function, you take the entire g function and plug it into all of the x's that are in the f function. Okay? So here's an example, and I'm going to use colors to try to help you as much as possible. First of all, f of g of x. This is also written like this, f of g of x, and I'm actually going to write it in colors. We're going to make f of x be pink and g of x be purple. So f of g of x means f of g of x. So I put the colors in there. We are going to take the purple function, 4x plus 7, and we're going to put it in place of the x in that f function. So in the f function, we have something minus 2. We are going to put that entire g function in place of the x in the f function. Then if we simplify this, there's nothing to multiply. The parentheses really don't mean anything when we're simplifying. So this becomes 4x plus 7 minus 2, which is 4x plus 5. So f of g of x is 4x plus 5. In the next one, they're doing g of f of x. That means g of f of x. We're going to be putting the f function inside the g function. So this time the f function, x minus 2, is going to go in place of this x in that g function. So the g function says 4 times something plus 7. That something is going to be the entire f function, x minus 2. Then distribute, this would become 4x minus 8 plus 7, so that would become 4x minus 1. G of f of x is 4x minus 1. Now notice, these two things are not the same. So 4x, like if you do f of g of x and then do g of f of x, you are not going to get the same thing. The order definitely matters. Now there's two ways that you can do part C and part D. One way is to say f of g of 5. Well, I know that f of g of x is this 4x minus or 4x plus 5, so I can just plug 5 into that. The other way to do it is to think of doing f of g of 5. So we're going to plug 5 into the g function, get an answer. Then we will plug that answer into the f function to get our final answer. So first we're going to take the g function, and we're going to do 4 times 5 plus 7. That's going to give us 20 plus 7. That's going to give us 27. Then we are going to do f of that. So then we are going to do that 27, plug 27 in place of the x, minus 2, and that's going to give us 25. So f of g of 5 means plug 5 into the g function, get your answer of 27. Take that 27, plug it into the f function to get your final answer of 25. G of f of negative 1, you would do that backwards. So you're going to do g of f of negative 1. So plug negative 1 into the f function, get your answer, then plug that answer into the g function to get your final answer. Pause the video, try that one on your own. So if we plug negative 1 in here, negative 1 minus 2 is negative 3. Then we are going to plug that into the g function. So 4 times -3 plus 7, that would be -12 plus 7, which is -5. Okay. Example 2. First, we need to do f of g of x, then we need to do g of f, or no, then we need to do f of g of -2. So again, if I use colors, my f function is going to be pink and my g function is going to be purple. If we are doing f of g of x, our f function is something plus 3. It's like you're taking this x and you're taking it out. You're just removing that x completely, and you're going to put this x squared minus 1 in place of it. So x squared minus 1, that g function goes in place of the x in the f function. Then simplify it. Now the parentheses don't really matter, so this becomes x squared minus 1 plus 3, so x squared plus 2. Okay, now there are 2 ways to do part B. Option 1, we are going to use that we know that f of g of x is x squared plus 2, and we're going to plug this -2 in place here. So -2 squared plus 2. -2 squared is 4, and 4 plus 2 is 6. Option 2. And this is the option I prefer because you don't always find f of g of x first. Sometimes it's just going to be find f of g of -5, and you're not going to have done that step beforehand. So option 2 is to take f of g of -2. Hold on. Don't know if you heard that. My daughter didn't want to flush because she knew I was recording a video. Okay, so this would be, we're going to take the g function, which is something squared minus 1, and we're plugging that -2 in there. -2 squared is 4, and 4 minus 1 is 3. Now we are going to take f of that. So we are going to do something plus 3. We're going to stick that 3 from here in there. And 3 plus 3 is 6. And ta-da! We got the same answer for both of those. So if you've already done f of g of x, if you've already done this part A, you can use your answer from part A to help you find f of g of whatever number. If you haven't done that part A and you're just being asked, here's 2 functions, find f of g of whatever number, do the inside one first. So plug the number into the g function or whichever one is in furthest on the inside, and then plug that answer into the f function. Okay, true or false? If f of x is x plus 1 and g of x is 6x, then f of g of x equals g of f of x. Here's what I'd like you to do. I would like you to find f of g of x right here on the left, and then on the right, I would like you to find g of f of x. And I want you to compare your answers. So pause the video, give both of these a try, and see what happens. Play the video when you think you're done or when you get stuck. For f of g of x, we are plugging that 6x, that g function, into the x of the f function. So the 6x is going in place of that x. We end up with 6x plus 1. When we do, oh my gosh, I can't figure that out. When we do g of f of x, we're plugging x plus 1 in place of that x, which means you need parentheses and you have to do 6 times all of that f function, x plus 1. We end up with 6x plus 6. Are these 2 things the same? They are not the same. So true or false? Definitely false. Okay, here's your assignment for 11.2, part 1.